In this video, I'm going to continue with some harder problems on factoring out a GCF of a polynomial. So just real quick, I want to review that GCF stands for greatest common factor, and it's what all your terms have in common. It's going to be the largest number that all your terms are divisible by in terms of coefficient. And then the letters, what you're going to notice is that the smaller power of the letters is what's going to come out in terms of your GCF. So I'm going to give it a whirl here with these 6 examples. If there's one you're looking for in particular, go ahead and fast forward through the video. For 10 and 60 and 30, the number that all 3 have in common would be the number 10. All 3 of those are divisible by 10. And then what I'm going to look for with my letters is the smallest power on the letters. So between my x's, the smallest power between the 8, the 10, and the 9 is 8. So the smallest is what you can take out in terms of power on a variable. For the letters, I have another letter y to the 5th, y to the 8th, and y to the 3rd. The smaller of 5, 8, and 3 is the number 3. That is going to be my GCF. Now we write what we get when we divide that out. So again, I want to review. We want to look for the largest number factor and the smallest power on your variables. Okay, now 10 divided by 10 is 1. I'm not going to write 1 because I want to see if I have anything else left over. X to the 8th, take out x to the 8th, there's none left over. Y to the 5th, if I take out 3, I'm left with y squared from my first term. There's a plus sign connecting my next letter, my next term. 60 divided by 10 is 6. If I have x to the 10th and I take 8 away, there are 2 left over for this term. Y to the 8th, if I take 3 of them out, would be left here with this term, 5 y's. So my middle term would be 6x squared y to the 5th after I take out the GCF. And then 30 divided by 10 is 3. X to the 9th, if I take 8 out, is 1. And y cubed, if I take all of them out, I have no y's left over in that term. So notice how in the parentheses, these 3 terms, all 3 of them share nothing in common. They are all completely different because there is not one thing that they all share. So this would be factoring out our GCF. Okay, again, between the number 30 and 10 and 12. It might take you a minute. You might need to write down the factors of each of those terms, but the only number that both of them share in common is the number 2. Now with my letters, between x here, the smallest power between 7 and 13 and 8 is 7. And for the letter y, between 10, 12, and 6, the smallest amount is 6. And now what I'm going to do is actually divide that out. 30 divided by 2 is 15. X to the 7th, if I take them all out, there's no x's left here that remain. Y to the 10th, if I take 6 of them out for the GCF, I'm left with 4. That's the end of my first term, so I'm going to put a plus sign to link my second term here. 10 divided by 2 is 5. Now I notice these have something in common, but I want to wait and show you that it won't have anything in common with the last term. 13 x's, if I take 7 away, there are 6 left over for this term. And if I had 12 y's and I took 6 of them out, there are 6 left for this term. Okay, now my last term. 12 divided by 2 is 6. Now the only common factor between 5 and 6 is 1. And the only common factor between 15 and 6 is also 1. And so I took everything out that I could. Actually, these have 3 in common, but these have nothing in common. So I can't take anything out from all terms, because I can't take a 3 out of this like I could out of those. Now my x's. X to the 8th, if I take 7 away, there's 1 left over. And y to the 6th, we took all of them out, and so we're done here with our factor that remains. I would give you a challenge. What I want you to do is pause the video now and try the other examples and see if you're understanding it, and then hit play and check your work. So here for this third example, 21, 35, and 14, the number that all of these are divisible by is a 7. Now between my letter x's, 5, 10, and 7, 5 is the smallest power. And for the letter y's, between 2, 4, and 8, the power of 2 is the smallest. And now we're actually going to divide that out of every single term. 21 divided by 7 is 3. If I have x to the 5th and I took them all away, there's no x's left over. If y to the 2nd, I took both of them out, there are no letters left over for that term. 35 divided by 7 is the number 5. Already I know that these have no factors in common, 3 and 5. 10 x's take away 5 would mean there are 5 left over. 4 y's take away 2 means there are 2 y's left over. Subtract for my next term. 14 divided by 7 is 2. Now I know there's no factors in common between 3 and 5 and 2. So I know we did that part right. X to the 7th, if I take 5 out, that means there are 2 x's left over. And y to the 8th, if I take 2 of them away, means for this term there are 6 y's left over that remain. And that is our GCF. All right, I got 3 more for us. We're almost done with the video, so just hang in there a couple more minutes. For this question over here, between 12, 11, and 6, there is no number in common here. So what we're going to do is take out essentially 1. But now I'm going to look at my letters. Between my letters, 9, 3, and 8, the smallest power is 3. Now I don't really need to take out a factor of 1, so I'm going to erase that. Otherwise, I would have said there's no common factor. So my numbers didn't get a factor taken out, so those numbers are all going to remain. But with 9 x's, if I took 3 away, I have 6 left over. Between 11 x cubed, if I took the x cubed out, I'm left with just 11. 11 is prime. Only 1 and 11 multiplied to be 11. And then for my 6th term here, if I had 8 x's and I took 3 of them away, that means there are 5 x's left over. Okay, now for my next term, 36 and 12. I noticed that between 36 and 12, I can actually take out a factor of 12 on both of those terms. Now for the letter x's, 5 and 8, 5 is smaller between the two. And for the y's, notice how there are 0 y's here. And 0 is smaller than 2, which means I cannot take y's out of my factors because this one has a smaller amount. There are no y's to take out, and so that would be my GCF. So 36 divided by 12 is the number 3. X to the 5th, I took all of the x's out. There's no x's left over. 12 divided by 12 is 1. X to the 8th, take 5 x's out. I'm left with 3. And I did not take any y's out, so just y squared. Again, I don't really need that coefficient of 1, so I'm going to erase that. There's nothing in common between 3 and an x cubed y squared. And so this would be my GCF here. Again, look for the largest number that you can take out as a factor and the smallest power on your variables. So if you have a term that doesn't have one of the variables, that means you cannot take it out as a GCF because not every single term has that to be taken out. Okay, one last problem over here between 19, 13, and 2. Well, 19 can only be made with 19 times 1, and 2 can only be made with 2 times 1. So there is no common number factor here. Let's see if they all have an x. It looks like they do. They actually all have one x. My power here, 1 is the smallest that we can take out. So 19, if I had 6 x's and I take 1 out, I'm left with 5. And for my 13 term, I had 2 x's, I take 1 out, so there's 1 left over. And for my 2 term here, I took the x away, and so that would be factoring out my GCF. X times 19x to the 5th plus 13x minus 2. Awesome job.